In this lecture, we will discuss problems related to the probability. So we start the problem 1. Question is that two coins are tossed. Find the probability of getting two heads. Second, getting at least one head. Getting at least one head मतलब कम से कम एक हेड होना चाहिए और मैक्सिमम पॉसिबल जितने भी सैंपल स्पेस में. थर्ड इज गेटिंग नो हेड. Getting no head. And fourth is getting one head and one tail. Getting one head and one tail. So when two coins are tossed, so first we write down the sample space. So the sample space S contain how many elements? Four elements. So when two coins are tossed, so that means the occurrence of both coins are head, one tail, one tail and head, one head, and both are tail. So the number of element in sample space S is equal to 4. So number of element in sample space equal to 4. Now we move to the first part. So getting two heads. So that means event. So this is the event of getting two heads. Getting two heads. So two heads means event E. E contain two heads means head. So this is the single element. So single elements means Ne. Ne contain only one element. Now we obtain the probability. Probability of getting two heads. So probability of getting two heads is equal to Ne upon Ns. So Ne means 1 upon Ns. Number of element in sample space is 4. So answer of first part is 1 by 4. Getting two heads. Now getting at least one head. So at least one head. So the second part. So we shall prove the second part. See the first part. So getting event, getting at least one head. So at least one head means minimum we have one head and more than is possible. So one head means one head that means at least one head. So head tail. Second is tail head and at least. So then head. So this is the possible events. So that may at least one head. So here we see that here is one head, and here is two heads. So at least one head we require. So there are three elements in the event E. So number of element in event E getting at least one head is 3. So probability P of getting at least at least one head is equal to Ne upon Ns. This will be 3 by 4. So second answer is 3 by 4. Now third answer for third question. So third question is that getting no head. So that means getting only tail. So third is event getting no head. So getting no head means that is tail. So event E contain only single elements, both are tail. So here we see that NE, number of element in E is equal to 1. So getting no head means both are tail. So probability of getting no head is equal to 1 by 4. And the last part, fourth part, fourth part says that getting one head and one tail. So event of getting one head and one tail. One head and one tail. So that means event E is equal to head, tail, tail, head. So containing two elements. So containing two elements. So this means that the probability P of getting one head and one tail is equal to 2 by 4. So here you can write down as NE. NE is equal to 2. So this equal to 1 by 2. So this is the answer of all four part. Now we move to the further questions. So that means next question is that a die is tossed. A die is tossed. So what is the probability of getting in short we write down as probability of getting a number 4, a number 4, second a number less than 5, a number greater than 4, greater than 4, a number 8. So when we toss a dice or throw a dice, so the sample space, throwing a dice, the possible outcome, means S contains six elements. 1, 2, 3, 4, 5, 6. The dice having six faces. So number of element in S is equal to 6. Now we move to the first part. So first part says that a number 4. A number 4. So event E getting a number 4. So getting a number 4, so that means event E contain only single element means NE is equal to 1. So probability P, so we are going to calculate the probability getting a 4. Getting a 4 is equal to, we write down as NE upon NS. So it means 1 upon 4. So the answer of first part is 1 upon 4. Second is getting less than 5. Less than 5. So getting event E getting less than 5. So less than 5 means 1, 2, 3, or 4. So 1, 2, 3, 4. So number of element in E is equal to 4. So NE, number of element in E is equal to 4. So probability P getting less than 5. So this is equal to NE upon NS. NE upon NS is equal to 4 upon 6. So means 2 by 3. Now third part is greater than 4. So event E getting greater than 4. So greater than 4 means 5 or 6. We have two elements. So that means any contain only two elements. So any contain two elements. So we calculate the probability of getting greater than 4 is equal to Ne upon Ns. Ne upon Ns equal to 2 by 6. This will be 1 by 3. And next is fourth part. Event E getting a number 8. So getting a number 8, when we throwing a dice, the dice having only 6 elements. That means 1, 2, 3, 4, 5, and 6. So event E contain only empty set 5, or we can write down as 5, means impossible event. So this type of event is called impossible event. So means impossible event. This type of impossible event. So that means there is no element. So we can write down the probability P of getting 8. So there is no element in E upon 6 is equal to 0. So 0 is the probability. That means for getting the number 8. Means this is impossible event. Now we take the other examples. In a single throw of two dice, in a single throw of two dice, find the probability of obtaining a total 8. Find the probability of obtaining a total 8. That means when two dice are thrown, so we are going to calculate the probability of obtaining a total 8. Total 8 means sum of two pairs, order pair elements is 8. So now single throw of two dice. So that means a sample space. So the sample space S contains 6 into 6 equal to 36 elements. Single throw of two dice. So 36 elements means ns equal to 36 elements. So how to write these 36 elements? We can write down the element as first dice when we get 1, another second dice also 1. We get first dice we get 1, second dice 2. First we have 1, second dice 3, 1, 4, 1, 5, 1, 6. Second dice having 2, 1. Next is 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. So similarly, we write down for 3, 1, 3, 2, 3, 4, 3, 5, 3, 6. So, so this contains the total 36 elements. So contains total 36 elements. Now, the event, we write down the event E getting a total 8. So how many elements are there in 36 elements who when we add two elements having the total is 8. So event E, event E we can consider as that means first element whose sum is 2 comma 6. So this one 2 comma 6, the sum is 8. Next will be 3 comma 5, 3 plus 5 8. Next equal to 4 comma 4, the sum is also 8. Next is 5 comma 3, the sum will be 8. Or next is 6 comma 2, the sum will be 8. So there are 5 elements in E whose sum is 8. So NE is equal to 5. So NE is equal to 5. So 5 element in E is there whose sum is 8. So now when we calculate the probability of getting a total 8, this gives us Ne upon Ns, this equal to 5 by 36. So this is our answer. So getting a total 8, the probability is 5 by 36. Now we move to the another questions. So next question we will take as a from a well shuffled pack of 52 cards, a card drawn at random. Find the probability, find the probability that the drawn card is red and a king, red and a king. Second, either a red or a king, either a red card or a king. So when we know that the well shuffled pack of 52 cards, so that means the sample space S contain 52 elements. So NS is equal to 52 elements. Now when we want to solve first part, red and a king, so event E getting a red and a king. So red and a king. So that means total red card in 52 cards is 26. And how many kings are there? So there are 4 kings. But the condition is that here we have a red card. The card is red and as well as king. So in 26 red cards, so there is 2 kings only. So card red भी होना चाहिए और उसमें king भी होना चाहिए. So end लगा हुआ है. So end लगा हुआ. This means that we have the intersection. Intersection means so we take the common elements between them so that there are 2. So the number of element in E is 2. So getting a red card and a king. So that means NE contain only 2 elements. So NE contain 2 elements. So the probability P of getting E is equal to 2 by 52 equal to 1 by 26. Okay. So now for second part, either a red card or a king. Either a red card or a king. So either a red cards. So either a red card, event E of getting either a red card or a king. Or means union. So red card, how many red cards is there? So 26 red card plus uh, or a king. So 20 in 26 red card, two king is already added, but two kings we are taken from the black card. So plus two. So that means event E contain how many elements? 28 elements. 26 plus 2 equal to 28. So 26 red cards. We have included two kings plus two kings we are taken from the black card. So their total is 28. So NE contain 28 elements. So when we calculate the probability P of getting E means either a red card or a king, which equal to 28 upon 52, NE upon NS. So NE upon NS. So 7 by 13. So these are the answers. Now we move to the next question. Next question is that a bag contains a bag contains 9 red balls and 12 white balls. One ball is drawn at random. One ball is drawn at random. So find the probability. Find the probability of drawn ball is red. So now we write down the sample space. So the sample space as sample space. So sample space on the basis of a bag. So bag contain 9 red and 12 white balls. So sample space S. That means number of element in S. So plus 9 plus 12. So sample space we taken as a bag. So 9 plus 1 is equal to 21 balls in a bag. The total balls are 21 in a bag. So this is our sample space. Possible outcomes. Now we move to the event. So event, what is the event? Event is getting at random. One ball draw at random. That ball is a red ball. Event E. So getting a ball is red. So total how many balls are red? So 9 balls are red. So NE, the number of elements in E is 9. So then probability of getting the ball is red is 9 by 21. So this is our answer. Now we have one note related to event. Let E be the event and E bar is the complement. E bar is the complement of E. So then the probability, the probability of E complement of E means E bar is equal to 1 minus probability of event E. So this thing you have to remember. So we will use this in questions for the complement events. Complement of E we denoted as E bar. Now we take one question related to that. So question is that if 3 by 10 is the probability that an event will happen, what is the probability, what is the probability that it will not happen, that it will not happen. So we do the solution of this. So we write down a let E be the event. So when E be the event, so the probability of event occurrence of an event is given as 3 by 10. So 3 by 10, so complement of E means it will not happen. So happened probability is 3 by 10. So E bar, E bar, so we write down as E bar, it will not happen. E bar be the event, it will not happen. So that means probability of event E bar is equal to 1 minus probability of event E. So directly we can write down as 1 minus 3 by 10 is equal to 7 by 10. 7 by 10 is the probability that event will not happens. So also we remember some important points. So one important point is that let S be the sample space. Let S be the sample space and E be the event. So then the probability of event is always greater than 0. So when an event is occur, so probability always greater than 0. Probability of impossible event phi is 0. It means that there is no event happens, and the probability of S sample space is 1. So maximum probability will be 1. So probability of sample space S ns upon ns equal to 1. So remember all these three things. Because for first one you can remember this thing, that means event E happens, event E is always subset of S. So that means we can write down as NE upon NS. So when event is happens, so then the probability should be greater than 0. Here phi, that means that is empty set. So N of phi means null set, so containing 0 element. So containing 0 elements means probability will be 0, n phi upon ns. Or here ns upon ns upon ns equal to 1. So you can remember so how to write down these things. Next, we have the theorem related to event. So let E1 and E2 are mutually exclusive events. Mutually exclusive event. So then first part, the probability of event E1 and E2. This can be written as probability of event E1 intersects and E2 will also will always equal to 0, because when two events are mutually exclusive, it means that E1 intersection E2 equal to 5. There is no common element between them. So when E1 intersection E2 equal to 5, so we use this P5, P5 equal to 0. So you can write down as P5, P5 equal to 0. Probability of impossible event is 0. Next, uh, second thing is probability of event E1 or E2. Or E2 means we take the union. So probability of event, the P of E1 union E2 can be written as probability of event E1 plus probability of event E2. So this thing we can use by using the addition theorem of two elements. The addition theorem of two elements, you know what is the addition theorem of two elements. So we have a probability of event E1 union E2 is equal to PE1 plus PE2 minus PE1 intersection E2. So for mutually exclusive event, this will be 0. So this gives us PE1 union E2 equal to PE1 plus PE2. So for general case, for general case, we can write down as probability of E1 union E2 union E3 union E4 dot dot union En. This always equal to probability of E1 plus probability of E2 plus probability of E3 plus and so on plus probability of event En. So we can write down one things where E1, E2, E3, En all are pairwise disjoint. So disjoint set means intersection equal to 5. So pairwise disjoint. So we have to remember addition theorem for two events. So P E1 union E2 already we have written above. So we write down a PE1 plus PE2 minus PE1 intersection E2. Or now we write down addition theorem of three events. So we have a PE1 union E2 union E3. This is equal to probability of event E1 plus probability of event E2 plus probability of event E3 minus probability of event E1 intersection E2 minus probability of event E1 intersection E3 minus probability of event E2 intersection E3 plus probability of E1 intersection E2 intersection E3. So this is the addition theorem for three events. Now, next theorem. So if E1 and E2 are mutually exclusive events, if E1 and E2 are mutually exclusive events, so we have a probability of event E1 plus probability of event E2 is equal to 1. So for mutually exclusive events. Next theorem, if E1 and E2 be two events and E1 is subset of E2, means all the element of E1 is element of E2. So we calculate the probability. So probability of event E1 is always less than equal to probability of event E2. Next thing is for any event E, for any, these are the important properties. For any event E, so the probability of event E always lie between 0 to 1.